So students, welcome to the session. In the last lecture, what we did, we have discussed the method how we can find out the solution of a system of linear equations using matrix inversion method. Actually, all those examples which we have discussed in the last lecture, they are of the same type. That is, in each case, we were getting the determinant of the matrix is not equals to 0. Therefore, the system Ax is equals to B, this is the system was having a unique solution given by x is equals to A inverse. But if you recall the conditions for consistency and inconsistency for system of linear equations, the system may be consistent, means it may have a unique solution, or it may have a multiple solutions or infinite solutions. Case 2, a system may be inconsistent, it means it may have no solution. So in the incoming examples, we will discuss few cases in which we will get condition 2, that is, the system may have no solution or a system may have a number of solutions or infinite many solutions. So let us take this example, solve the following system of equations. This is our system, right? This is a system having two equations, and in fact it contains two variables x and y, right? So the approach, as I have discussed, I have told you many times, the approach for finding out the solution of a system of linear equations, whether it contains two variables and two equations, or it may contains three variables or three equations, will remain verbatim, right? So this is a system of two equations in two variables. So we have to find out its solution. So as usual, we know the given system of equations can be written as Ax is equals to B, right? What is A? A simply refers the matrix of the coefficients of the variables involved in the given equations. That is here x and y. Clear? Here x and y are the two variables. X is as usual the matrix of the variables, and B is the constant terms which are lying at the right hand side of the given equations. So this above system of equations can be written in the matrix form like this: Ax is equals to B, where A is the matrix this. So A, take it here, I have told you many times the process of writing down the matrix A. The coefficient of x in the first equation is 3, the coefficient of y in the first equation is 11. So 3 and 11 is considered as the first row of the given matrix. 9 is the coefficient of x and 33 is the coefficient of y in the second equation, therefore 9 and 13. So this is taken as the matrix of the coefficients of the variables x and y. And x is as usual because these equations contains two variables x and y. B is the constant terms which are lying at the right hand side, that is 15 and 9. Though this is our system, Ax is equals to B, means the matrix notation, right? Now the first step is what? Find out the determinant of the given matrix. So determinant of the given matrix can be written like this: 33, this is 33. So 33 into 3, 99, and 11 minus 9 is 99, that is equals to 0. So what we get? This is our system, and the determinant of A is equals to C. So this is the case 2. And if you recall the conditions for the existence of the solution, if determinant of A is identically 0, then we have two possibilities. Either the system will be inconsistent, means it will have no solution, or the system will have infinite many solutions. So what we did for that, we calculate the adjoint of A first, and this adjoint of A should be multiplied with the matrix B. Clear? And see what happens in this case. So this is the matrix A. You know how we will calculate the adjoint of A. Adjoint of A by our shortcut method. These two diagonal elements should be flipped and they should be multiplied by minus, right? So this is the adjoint of the matrix A. You can also calculate the adjoint by using the formal method, that is calculate the cofactors of all the four elements, then write down its matrix of the cofactors and finally take its transpose, right? So the adjoint of A is this, and if adjoint of A is multiplied with the matrix B, that is B is 15 and 9, the product is coming out to be a non-zero matrix, 396 and minus 108. So determinant of A is 0 and adjoint of A and B is coming out to be non-zero, and you know this implies the system is inconsistent. Inconsistent means no solution, right? Adjoint of A into B is not equals to 0, then the system is inconsistent, it has no solution. And if adjoint of A into B is equals to 0, then the system is consistent and it will have infinite many solutions, right? So this is how we can also discuss case 2 if the determinant of the matrix identically vanishes or 0. Here, this is also a system of equations involving two variables x and y. So solve the following system of equations. This is again a system of two equations in two variables x and y. So see what kind of solution it will have, right? The given system, this can again be written as Ax is equals to b, right? So what does it mean? Ax is equals to b, where A, you know, matrix of the coefficients of the variables x and y. X as usual the matrix of the variables and b is the constant quantities at the right hand side. So this is our A. This is x and this is 2, 4 is b. X, coefficient of x in the first equation is 1, coefficient of y in the first equation is minus 3. So 1 minus 3, coefficient of x in the second equation is 2 and coefficient of y in the second equation is 6. So 2 minus 6. So this is how we can write down the matrix, right? So this is the system Ax is equals to b. Now write down its determinant as a first step. Its determinant is coming out to be 0, right? So naturally, if determinant of the matrix is equals to 0, then what we did, we calculate the adjoint of A and multiply it with B. It is either a null matrix or a non-zero matrix. So adjoint of A of this matrix is what? By the shortcut method, this is what? These two elements should be flipped, minus 6 and 1, and these two elements should be multiplied with minus sign. So this is the adjoint of the matrix A. Multiply this adjoint with the matrix B, and the product of these two matrices is coming out to be a null matrix. So this is identically 0. And if you recall the conditions for existence of the solution, if adjoint of A into B is identically 0, then it shows that the system is having infinite many solutions. So hence the equations have infinite many solutions, right? Now I have already explained the process of writing down the infinite many solutions. Infinite many solutions means, solution means what? Solution means the values of x and y which must simultaneously satisfy these two equations. This is the meaning of solution. So if x is any number and y is any other number, it means x is equals to 5 and y is equals to 2. This is the only one solution. The variable x is equals to the number 5 and the variable y is equals to number 3. If I write x is equals to c and c is any constant, if c is 0, then x is 0. If c is 5, then x is 5. If c is minus 10, then x is minus 10. So x completely depends on c. So c being a number or a constant can have infinite many values. Therefore, x can also have infinite many values. Clear? So infinite many solutions means the values of x and y, they will contain a constant. And by changing that constant, the values of x and y will also change. This is the meaning of infinite many solutions. And the process of writing down the solution of equations having infinite many solutions means what? Here we are having two variables x and y, right? X and y, they are the two variables. We can take any variable as c. If I take y is equals to c, a constant, then what is the value of x? Then c, x is equals to, from equation 1, 2 plus 3y, and x is equals to 2 plus 3c. So the solution is what? X is equals to 2 plus 3c and y is equals to c is considered as the solution of these two linear equations. C is here, and c being a constant, as the value of c will change, the values of x and y both will change. And naturally, c being a constant can have infinite many values. Therefore, x and y will also have infinite many values. In such cases, we say that the problem is having infinite many solutions. Clear? So I think all the cases of the consistency and inconsistency, the system may have a unique solution, or a system may have infinite many solutions. In case of inconsistency, the system will have no solution. This is also another case. See, I have taken this problem as a word problem so that you can understand how the system of linear equation works in our practical fields. A purchased 3 pens, 2 bags and 1 copy and pay rupees 41. So try to understand the language. A purchased 3 pen, 2 bags and 1 copy and pay rupees 41. From the same shop, B purchased 2 pen, 1 bag and 2 copies and pay rupees 29. While C purchased 2 pens, 2 bags and 2 copies and pay rupees 41. Transform the problem into system of equations and then solve the system of equations by matrix inversion method, and hence find the cost of 1 pen, 1 bag and 1 copy. So solution of x of the system of equations means what? Determine the values of x, y and z, right? That will simply represent the cost. So what is happening here? There are three candidates, A, B and C, and what they are doing, A is purchasing 3 pens, P for pen, 2 bags, B for bags, 1 copy, C for copy, and it pays rupees 41. Clear? B purchase 2 pens, 1 bag and 2 copies and pay rupees 29. While C purchases 2 pens, 2 pens, 2 bags and 2 copies and pay rupees 44. This is the data or situation of the problem. Now we have to transform this word problem to the mathematical equations. So what are the items? There are 3 people, they are purchasing 3 kinds of items: pen, bag and copies. Clear? So what we will do, let the price of 1 pen is x. and the price of one bag is Y, and the price of one copy is Z. Clear? What we are doing, let us denote the price of a bag is X rupees. Price of a pen, so let us denote the price of a pen is X rupees, price of a bag is Y rupees, and price of a copy is Z rupees. Clear? Respectively. So from the given data, if the cost or the price of a pen is X, then the price of 3 pens will be 3X. If X is the cost of a one pen, then 3 pens will cost 3X, right? So what we will get here, 3X plus twice of Y plus Z is equals to 41, because the total cost incurred in purchasing these 3 items is rupees 41. So first equation is what? 3X plus 2Y plus 1Z is equals to 41. This is equation 1. In second case, twice X plus Y plus twice of Z is 29. This is equation 2. Third is twice of X plus twice of Y plus twice of Z. This is equals to 41. Clear? So this is how we can transform the data given in word problem into the mathematical equations. Now we know how to find out the solution of these 3 equations having 3 variables X, Y and Z. So use the approach what we have used in the last examples. One step is what? Transform these given equations to the matrix form, that is Ax is equals to B. So the above system of linear equations may be written as Ax is equals to B. Clear? Where A is the matrix, X is this, B is this. You know what is A? A is simply the matrix of the coefficients of the variables X, Y and Z involved in these equations. X, as usual, the 3 variables X, Y and Z, and B simply denotes the constant quantities which are lying at the right hand side of the given equation. Clear? A, the coefficient of, for example, the coefficient of X in equation 1 is 3, the coefficient of Y in equation 1 is 2, the coefficient of Z in equation 1 is 1. So 2, 3, 2, 1. Here the coefficient of X is 2, coefficient of Y is 1, coefficient of Z is 2. So 2, 1, 2. In the third, coefficient of X is 2, coefficient of Y is 2 and coefficient of Z is 2. So 2, 2, 2. This is how we can write down the matrix of the coefficients of the variables X, Y, Z, right? Now after that, the first step is what? We will find out the determinant of the matrix A. So the determinant of the matrix A is this, and if you simplify this determinant, its value is coming out to be -4. Okay. Find out the value of this determinant. I have explained many ways to find out the values of the determinant. So if we will determine the value of this determinant, it will come out to be -4. It means this is not equals to 0. The matrix is not non-singular. Therefore, the system Ax is equals to B will have a unique solution that is given by X is equals to A inverse B when if determinant of A is not equals to 0. Here the determinant of A is not equals to 0. So we will find out the inverse of the matrix simply, and this inverse of the matrix should be multiplied with the matrix B to get the values of the variables X, Y and Z. Clear? Now you can proceed. So to find out the inverse of a matrix, what we will do, we will calculate the adjoint. And for calculating the adjoint, first you will have to find out the cofactors of all the elements of the determinant A, right? So here I have mentioned the cofactors. A11 is -2, A12 is coming out to be 0, and then so on. I have already explained the procedure or the approach to find out the cofactors of the elements of a determinant. You should do it yourself. So these are the cofactors as written here. After that, what you will do, write down the matrix of the coefficients of the cofactors. That is, the matrix is A11, A12, A13, A21, A22, A23, A31, A32 and A33. This is the matrix of the coefficients of the cofactors. And then take its transpose. This will give you adjoint of A, right? This is all we have done. So see in the next slide, adjoint of A, this is what? This is the matrix of the cofactors of the elements of the determinant A, right? When we will take its transpose, we will get this matrix as adjoint. And transpose, how we determine, you know, the rows and columns of a matrix must be interchanged, right? See here, this is the first row, -2, 0, 2. It should be converted to the first column. So -2, 0 and 2. Clear? The second row is -2, 4 and -2. It should be converted to the column 2, -2, 4, -2. The third row is 3, -4, -1. It should be converted to the third column, that is 3, -4, -1, right? So this is what? This is the adjoint of the matrix A. And we know that if adjoint of a matrix is with us, then A inverse is always equals to adjoint of A divided by determinant of A. Determinant of A we have already calculated, that is -4. So A inverse is equals to minus times 1 upon 4. This matrix adjoint, right? Multiply -1 upon 4 inside this matrix, you will get this matrix, right? This is A inverse, right? And once A inverse is there, you know the solution is what? X is equals to A inverse of B. So multiply this inverse with the matrix B, which is already known. The resultant product of these two matrices will give you the value of the matrix X. So X is equals to A inverse B. This is A inverse, this is B. Multiply these two, the values of X, Y, Z. X is equals to what? X, Y, Z. This is coming out to be 2, 15 and 5. By equality of two matrices, X is 2, Y is 15 and Z is 5. So this is the cost of each product. Means X was the cost of a pen. The cost of a pen must be rupees 2. Y was the cost of a bag. So the cost of a bag should be rupees 15. And Z was the cost of a copy. So the cost of one copy should be equals to rupees 5. So this is how we can solve some word problems also by using the same concept. This is also another case of something little bit different rather than all the questions which we have solved, but the approach in this question is also will remain the same. So let us take up what is given here. The daily cost C operating a hospital is a linear function of inpatients, that is P, and outpatients, that is Q, plus cost A. P is the number of patients who are in, Q number of patients which are out, and A is the cost, is given by this function. C is equals to A plus BQ. C is equals to A plus BQ plus D of P. This is our function. Sorry, Q is capital. C is equals to A plus BQ, right? Given the following data for 3 days, find the values of A, B and D. So we have to determine the values of A, B and D. by setting up a linear system of equations using the matrix inversion method. Clear? So the data here given in this table, there are 3 days, 1, 2, 3. This is the cost for day 1, cost for day 2, cost for day 3. This is the number of patients, inpatients, that is P. This is the number of patients, outpatients, that is Q. So what you will do here, this is your general function. Put the values of the inpatients, outpatients, and the cost. You will get 3 equations because the data is given only for 3 days. One equation for first day, one equation for second day, and one equation for the third day. See, what is the cost for the first day? The cost for the first day is 6950. That is C. This is equals to what? A will remain as it is. A is not given. What is B and what is Q? Q denotes outpatients. So this is what? 10 times of B plus D and P. P denotes the inpatients, that is 40 times of D. Right? This is equation number 1. So see, this is our equation 1. Similarly, construct the equation for day 2. Here the cost is 6725. This is equals to A will remain as it is plus Q here is now 9 times of B and P here is 35 times of D. This is equation number 2. And for the third day, the cost is now 7100. This is equals to A plus inpatients are 12 of B plus outpatients are 40 of D. So this is equation 1, this is equation 2, this is equation 3. 1, 2 and 3. We are getting the same equations. Now, this is what? This is a system of, look at these 3 equations carefully. This is a system of 3 equations in 3 variables. And the variables here are what? A, B and D, right? Till now we were having the variables as X, Y and Z. I have told you in the beginning of this session the variables may be changed. So here the variables X, Y, Z are replaced by the new variables A, B, D. So solution of this system means determine the values of A, B and D which simultaneously satisfies the given system of equation. Now the procedure will remain as it is. First step is what? Transform these 3 equations into the matrix form, that is Ax is equals to B. Clear? So Ax is equals to B, where what is A? A is the matrix of the coefficients of the variables A, B and D. Be careful. I am repeating it once again. Here A is the matrix of the coefficients of the variables A, B and D, because in these 3 equations the variables are now A, B and D, not X, Y and Z, right? So this A is the matrix of the coefficients of the variables X, as usual the variables A, B and D, and B, you know, the constant quantities lying at the right hand side. So this is your A, coefficient of A here 1, here coefficient of B is 10, here coefficient of D is 40. So 1, 10, 40. In equation 2, 1, 9, 35, 1, 9, 35. In equation 3, 1, 12, 40, 1, 12, 40, right? Now, X is what? A, B and D, not X, Y and Z. Be careful. B is the constant quantities at the right hand side. Now, I hope you can find out its solution yourself. First, find out its determinant. Its determinant is coming out to be 10. And if determinant of A is not equals to 0, it shows that the system is having a unique solution, and which is given by X is equals to A inverse B. B is with you. What you want to calculate? Simply calculate A inverse from the matrix A and multiply this A inverse with the matrix B. The resultant product will give you the values of the variables a, b and d, right? Let us see in the next slide. Determinant of a is not equals to 0, therefore A inverse exists, and the solution of the system is given by x is equals to A inverse b. This is the adjoint. I request all these students calculate the adjoint yourself for the sake of practice. Okay, don't follow what I have written. Adjoint of A is this. Now using the formula of A inverse is equals to adjoint of A divided by determinant of A. When you will simplify this, so what is the inverse of the matrix is this. Now finally the solution is given by x is equals to A inverse b. So multiply this matrix with this matrix and make all these calculations. After going through all these calculations, the values of A, B, C, 5000, 75 and 30. So A is coming out to be 5000, B is coming out to be 75 and D is coming out to be 30. So this is how we can calculate the values of the variables. Students, if you recall, when we were doing the Cramer's rule, we have considered two kinds of system. One was Ax is equals to b and second was Ax is equals to 0. This is known as non-homogeneous, right? And this is known as homogeneous. So till now, the system we have considered, in all cases it was Ax is equals to b, that is non-homogeneous system, right? Now, if b is equals to 0, the right hand side terms are identically vanishes 0, then the system becomes Ax is equals to b, then this system is known as homogeneous, right? And the homogeneous system Ax is equals to 0, we have also discussed, is always consistent, right? Always consistent. It will have a solution, but it will have two kinds of solution. A trivial solution or a non-trivial solution depends upon determinant of A. If determinant of A is not equals to 0, then it will have a trivial solution. And if determinant of A is equals to 0, then it will have infinite solutions, right? This is left to be discussed. Let us take within few moments. Homogeneous system of linear equations. The system Ax is equals to b is called homogeneous if b identically vanishes. That is, all the constant terms lying at the right hand side of the given equations are identically 0. So the system will become a11 x1, a12 x2, a13 x3 is equals to 0. All the equations will remain same except these terms will become 0. Second equation is a21 x1, a22 x2, a23 x3 and then so on. As usual, this system of equations can be written as Ax is equals to 0 because b is 0. This system can be written as Ax is equals to 0, where A is as usual matrix of the coefficients of the variables x1, x2 and x3 are x, y and z. X is what the variables involved in the given equation. Homogeneous system of linear equations is never inconsistent. It is always consistent, right? Let us take an example very quickly. Solve the following system of equations. This is a system of three equations in three variables. So before proceeding the solution of this system, let us check or identify this system is homogeneous because all the terms lying at the right hand side, they are identically 0. Clear? So naturally, the given system of equations can be written as Ax is equals to 0. A is matrix of the coefficients of the variables x, y, z because x, y, z are here variables. So the matrix of the coefficients of the variable a is given by this. This is your a. And x is the three variables involved, that is x, y and z. The approach is as usual. Step 1 is what? Find out the determinant of the given matrix. So determinant of the given matrix is this, and if we simplify it, its value is coming out to be 17. So what is we are getting? Determinant of A is not equals to 0, and this implies the system AX is equals to 0, means homogeneous system will have a trivial solution, right? Trivial solution means the values of x and y both are 0, right? So system is having trivial solution, that is z is also 0 because there are three variables, right? Let us take this case also. Solve the following system of equations. This is again a system of three equations in three variables x, y and z. But here also all the terms lying at the right hand side are identically 0. Therefore, we can express the system of equations into the form Ax is equals to 0, where A is as usual matrix of the coefficients of the variables x, y, z. See, coefficient of x is 3, coefficient of y is -5, coefficient of z in 6 in equation 1. So 3, -5 and -6. Likewise, in equation 2 as well in equation 3. So this is A and this is X, right? We have written the given system of equations into matrix form, that is Ax is equals to 0. Now use our steps as usual. Determinant of A is coming out to be 0. Oh. So determinant of A is equals to 0, then the system Ax is equals to 0 has infinite many solutions, right? The system has non-trivial solutions, that is determinant of A is equals to 0. Solution can be classified in two categories in case of homogeneous. Trivial means the values of the variables are 0. Non-trivial means the values of the variables are different from 0. So in this case, the system has a non-trivial solution, of course, that is the case of the problem having infinite many solutions. So how we will calculate infinite many solutions? Let us have this. The system has a non-trivial solution because determinant of A is equals to 0. Now we will determine the infinite number of solutions from these three equations, right? So a number of ways are available to find out the infinite many solutions. Here we have used the approach which we all have done at our 9th and 10th standard, that is known as cross multiplication, right, method. This is the simplest method which you can use. We can use the method of cross multiplication. How does it work? See, x, y and z, right? X, y and z, they are the three variables. See, x, so we write it like this: x is equals to y is equals to z, right? Now, what should be there in denominator of x? See this equation, x, remove the coefficients of x. What are the coefficients of y and z? See, the coefficient of y is -5 here, multiply this with -5. Coefficient of y and z, they should be multiplied, cross multiplied like this, right? This minus this. So -5 into -5, that is 25. Minus 2 into 6, that is 12. 25 minus 12, what we will get? X upon 13, case 1. Now what is y? Take the terms of y. So the terms of y should not be considered here, and again use the process of what? Cross multiplication like this. 3 should be multiplied with 5. So 3 into 5 minus 15. And what is here? 4 into 6, that is 3 into 5 is minus 15, 4 into 6, 24. So this is equals to y divided by minus 39, right? This is 39 and this is z is equals to similarly 26. And what is this? This is equals to, we take a constant. So what does this mean? X upon 13 is equals to c. This implies x is equals to 13. You can divide by all 13. See, before proceeding the solution, divide by 13. So what you will get? X upon 1, y upon 3, 3 the 13, and z upon 3 to the 16. This is c. So see, x upon 1 is equals to c. This implies x is c. And similarly, y upon 3 is equals to c. This implies y is 3c. And z upon 2 is equals to c. This implies z is equals to 2c. So x is equals to c, y is equals to 3c, and z is equals to 2c. They are the solution of the system of equation c, as I have discussed in the last example. C means the value of c may change. So that is why we say that such kind of problems are having a solution, but the solutions are infinite in nature. So this is a problem having an infinite number of solutions, right? So students, I think I should stop it here and I will continue in the next lecture. Thank you very much.